Hey guys, today we're going to do 1-6 absolute value equations and inequalities. Our objective is to write and solve equations and inequalities involving absolute value. An absolute value quantity is non-negative. So since opposites have the same absolute value, an absolute value equation can have two solutions. You can write an absolute value inequality as a compound inequality without an absolute value sign. So, absolute value. The definition of absolute value is the absolute value of a real number, x, written the absolute value of x, is its distance from 0 on the number line. So, the absolute value of 4 is 4, and the absolute value of negative 4 is 4. So, an absolute value equation has a variable within the absolute value sign. For example, the absolute value of x is equal to 5. Here, the value of x can be 5 or negative 5 because the absolute value of 5 and the absolute value of negative 5 both equal 5. Solving an absolute value equation. What is the solution of the absolute value of 2x minus 1 is equal to 5? Graph the solution. So, when we are solving absolute value equations, we need to get our absolute value by itself, and then we're going to split it into two equations, because the absolute value can be equal to 5, and it can be equal to negative 5. So we split it, one positive equation, one negative equation. Now solve for x. X is equal to 3. And x is equal to negative 2. We can graph that by, on a number line, negative 2 and 3. Would be the graph of our solution, and you need to check. So take 3 and plug it in. 2 times 3 minus 1 is 6 minus 1 is 5. The absolute value of 5 is equal to 5. And negative 2. The absolute value of 2 times negative 2 minus 1. Negative 4 minus 1 is the absolute value of negative 5 is equal to 5. Check. They both work, so they are both our solutions. Solving a multi-step absolute value equation. So here we need to isolate our absolute value first. So this is our absolute value. And before we split it up into two equations, get that by itself first. So I'm going to add 1. So 3 times the absolute value of x plus 2 is equal to 9. Now I'm going to divide by 3. So the 3 cancels, and I'm left with the absolute value of x plus 2 is equal to 3. Now that my absolute value is by itself, I can split it into two equations. The absolute value goes away. And I have x plus 2 is equal to 3, and x plus 2 is equal to negative 3. Isolate for x, so I'm going to subtract 2. X is equal to 1. Subtract 2. X is equal to negative 5. It asks me to graph and check my solutions again, so I graph 0, 1, 2, 3, 4, 5. 1. Graph my solutions. To check, I plug in. So 3 times 1, the absolute value of 1 plus 2 minus 1. 1 plus 2 is 3. The absolute value of 3 is 3. 3 times 3 is 9. 9 minus 1 is 8. Check. And my second solution was negative 5. So 3 times the absolute value of negative 5 plus 2 minus 1. This is the absolute value of negative 3, which is 3 times 3, which is 9 minus 1, which is 8 again. So those are both x equals 1 and x equals negative 5 valid solutions. The distance from 0 on a number line cannot be negative. Therefore, some absolute value equations, such as the absolute value of x is equal to negative 5, have no solution. So it is important to check the possible solutions of an absolute value equation. One or more of the possible solutions may be extraneous. An extraneous solution is a solution derived from original equation that is not a solution of the original equation. So even though it comes out as an answer, we have to make sure that the solutions we get work in our equation. If they don't work, then they would be considered extraneous solutions. Checking for extraneous solutions. What is the solution of the absolute value of 3x plus 2 is equal to 4x plus 5? We need to check for extraneous solutions. So, once again, 3x plus 2 is isolated, so I can separate it. 3x plus 2 is equal to 4x plus 5, and 3x plus 2 is equal to the opposite of 4x plus 5. Solve for x. Negative 3 is equal to x. This would be negative 4x minus 5, so I'm going to add 4x to both sides, and I'm going to subtract 2. So 7x is equal to negative 7, divided by 7, x is equal to negative 1. Check our solutions. The absolute value of 3 times negative 3 plus 2 is equal to 4 times negative 3 plus 5. The absolute 3 times negative 3 is negative 9 plus 2 is equal to negative 7. The absolute value of negative 7 is 7. Negative 12 plus 5 is equal to negative 7. 7 and negative 7 are not alike, therefore negative 3 is not a solution. That does not work. Then try negative 1. The absolute value of 3 times negative 1 plus 2, this is absolute value, I'm sorry. Negative 3 plus 2 is the absolute value of negative 1, which is 1. Then we have the other side of the equation, which is 4 times negative 1 plus 5, which is 1. So 1 and 1 work. Therefore, our solution is x is equal to negative 1 with an extraneous solution of x is equal to negative 3. The solutions of the absolute value inequality, absolute value is less than 5, include values greater than negative 5 and less than 5. This compound inequality, x is greater than negative 5 and x is less than 5, which you can write as negative 5 is less than x, which is less than 5. So the absolute value is less than 5 means x is between negative 5 and 5. What is the solution of the absolute value of 2x minus 1 is less than 5? So we know that 2x minus 1 is between negative 5 and 5. I can solve this compound inequality just whatever I do to The left side I need to do to the right side. So I'm going to look at the middle and I'm going to add 1. But I'm going to add 1 to the outside, both outsides. And therefore I'm left with negative 4 is less than 2x, which is less than 6. And I am now going to divide by 2. Negative 4 divided by 2 is negative 2, is less than x, which is less than 3. So that is your solution, and to graph that, we need our number line. Zero, negative 2, and 3. We are greater than negative 2, but less than 3. So our solutions are between those two values. What is the solution of the absolute value of 2x plus 4 is greater or equal to 6? Greater or equal to 6. Greater means that we have an or inequality. So that means we're going to have two inequalities. We're going to split it up as 2x plus 4 is greater or equal to 6, or 2x plus 4 is less than or equal to negative 6. I flip the sign when I take the opposite of the right side. That's why it is less than negative 6. And now solve. So we're going to subtract 4x. 2x is greater than or equal to 2. Divide by 2. X is greater than or equal to 1. Subtract 4. 2x is less than or equal to negative 10. Divide by 2. X is less than or equal to negative 5. I then draw them on my graph. Greater or equal to 1. Less than or equal to negative 5. So our first absolute value inequality was less than, and that was an and inequality. When it is greater, it is an or inequality. That is what we're going to go over here. Once you have these definitions and graphs done, that's all for absolute value equations and inequalities.